Coordination compounds. Weightage 9 marks. 3 marks 3 question. 1 mark questions. Question 1. What is the IUPAC of K2, zinc, O2? Answer. Potassium tetrahydroxidose K2. Question 2. Write formula for the mercury tetrathiocyanatocobaltate 3. Answer. HgCO(SCN)4. Question 3. How many silyns can be precipitated as AgCl by adding excess of aqueous AgNO3 solution into 1 mole of CONH3, 6Cl3? Answer. 3, 3, icons A3. Question 4. What is the value of coordination number of Fe in Fecl2 and 2Cl? Answer. 6. 2 mark questions. Question 5. What is an embedentate ligand? Give an example. Answer. Ligand which can ligate through 2 different atoms to central metal atom, ion is known as embedentate ligand. Example. Nitrito-N and nitrito-O are number 2 OR thiocyanate and isothiocyanate OR SCN and NCS, Ne1. Question 6. What is chelating ligand? Give an example. Answer. When a didentate or polydentate ligand uses 2 or more donor atoms to bind single central metal atom, ion is known as cheating ligand. Example. Ethane 1,2-diamine, N, ethylene diaminotetraestate, EDTA, ion, oxalate, C2O4, etc. Question 7. What are homoleptic complexes? Give an example. Ne1. Answer. Complexes in which a central metal atom, ion is bound to more than one kind of donor groups are known as heteroleptic complexes. Example. THO, CO, CN, 6, 3, CO, H2O, 4, 2, Ni, Cn, 4, nickel 4, Co, N3, etc. Question 8. What are heteroleptic complexes? Give an example. Answer. Complexes in which a central metal atom, ion is bound to more than one kind of donor groups are known as heteroleptic complexes. Example. Kochi, Cn, NO2, NH3, 3, Co, NH3, 5, NO2, Cl2. Co, NH3, 5, NH3, 5, ONO, Cl2, etc. Question 9. Mention any 2 postulates of Werner's theory of coordination compound. Answer. I. The central metal atom or ion in a complex possesses 2 types of valences, linkages, namely a primary valency B, secondary valency E. Primary valency is ionizable and secondary valency is non-ionizable. E. Primary valency is satisfied only by anions, negatively charged ions, and secondary valency is satisfied by either anions or neutral molecules or both. IV. The primary valency corresponds to the oxidation state of central metal and the secondary valency corresponds to the coordination number of the metal, remains fixed for a metal. V. The secondary valences are directional. Hence they show isomerism. V. The primary valency of the metal is variable. The secondary valency has a fixed value. Question 10. Draw energy level diagram for the splitting of d orbitals in an octahedral crystal field. Answer. Three marks questions. Question 11. On the basis of valence bond theory, VBT, account for hybridization, geometry and magnetic property of Ni, Cn, 4, 2 complex ion. Z for Ni is 28. Answer. Hybridization, DSP squared geometry, square planar magnetic property, diamagnetic. Question 12. Using valence bond theory explain geometry hybridization and magnetic property of curve. Given atomic number of county is 27. Answer. Hybridization, sp cubed d2 geometry, octahedral magnetic property, paramagnetic. Question 13. Using valence bond theory, explain geometry, hybridization, and magnetic property of Co. NH3, 6, 3, given atomic number of count is 27. Answer. Hybridization desk cube geometry, octahedral magnetic property, diamagnetic. Question 14. On the basis of valence bond theory, VBT, account for hybridization, geometry and magnetic property of nickel 4, complex ion, Z for Ni is 28. Answer. Hybridization, sp cubed geometry, tetrahedral magnetic property, paramagnetic. Question 15. Discuss the nature of bonding in metal carbonyl, 3D. Answer. In metal carbonyl, the metal-carbon bond possesses both an character. The metal-carbon O bond is formed by the donation of lone pair of electrons on the carbonyl carbon into vacant orbitals of metal. The metal-carbon bond is formed by the donation of a pair of electrons from a filled d orbital of metal into the vacant antibonding orbital of CO. The metal-to-ligand bonding creates a synergic effect which strengthens the bond between CO and metal. Question 16. What is crystal field splitting energy? Name two factors on which crystal field splitting energy depends. Answer. The energy separation in the splitting of the degenerated levels due to presence of ligands in a definite geometry is known as crystal field splitting energy. OR. The difference in energy between the two sets of degenerate orbitals during crystal field splitting is called as crystal field splitting energy. The crystal field splitting energy depends on 1. Field produced by the ligand. Strength of ligand. 2. Charge on the metal ion. Question 17. Define spectrochemical series. Answer. A series of ligands arranged as the increasing order of their ligand field strength is called spectrochemical series.